Fabric is a very exciting product, but it has that elasticity to only pay for what you use, but managing that elasticity can be a challenge. So we know that this is a challenge in the marketplace right now. So we're trying to be timely with our subjects, and sounds like there's plenty of people that are interested in learning more about this. So so excited to talk about this topic, and grateful that that you all joined. Pierre Laframboise will be leading this this presentation, but if you don't mind, we'll let him get through his presentation. So if you have questions throughout the presentation, please enter them in the chat or hold them to the end. We do plan to leave time at the end for Q&A, so we'll be able to take everyone off mute. And please do mute we won't mute you as long as everyone is good citizens. Please do mute yourself. Or we will mute if needed. We are recording this event, so if you do want a recording, you can either let us know in the chat, or you can email Michelle at mwork@mailctp.com, and we'll provide that. So with that, let me move on to our a couple of key questions. So we always like to tailor this event to the folks that are here. So and we're gonna do a little survey here. So so first, are you currently using Power BI in production? So if you don't mind answering that question. And okay. And then, are you using Power BI Premium? Again, yes, no, or not sure. If you're not sure what version, what flavor of Power BI you're using, that's fine. All right. On what platform is your current data analytics environment? If it's on-prem, if it's in the cloud, or if you don't have a data analytics environment. So in other words, what we mean by that is if you don't have a data warehouse or a significant data mart or a data lake where you're already aggregating data from disparate data sources, that's what we're referring to there. So if you're just using your source system data, that would be an example of don't have a data analytics environment. Have you used Microsoft Fabric? So again, it's relatively new. So just curious to know if you're already using it in production, if you're just playing with it, or perhaps working on a project to deploy it soon, or if you're just either thinking about it or just trying to learn more about it. That's fine, but just curious to know where everyone is. All right. So with that, we'll get into the agenda. So so we'll start with we'll do introductions. We're going to start with a brief overview of Fabric concepts. Now, just a heads up, this is almost more of a 200 level presentation. So we're assuming that you know kind of the fundamentals of Fabric. If you're not familiar with the fundamentals, with the basics of Fabric, we actually did another webinar, gosh, like a month, 2 months ago, that really covered the basics, the fundamentals. And we have that recorded. So if you'd like to check out that presentation, please just let us know in the chat or send an email, and we can provide you that presentation as well, and that'll cover more of the fundamentals. So if we're talking about things today and you're like, gosh, not sure what that is, one, ask questions, or two, we have those resources available to kind of give more of the fundamentals. So just be heads up, this is really a 200 level presentation. So we're going to talk about capacity basics. We're going to talk about understanding capacity consumption, managing capacity resources, and then introduction to Fabric Capacity Metrics app. And then, like I said, we plan to leave time for Q&A at about 2:50 Central Time. So with that, I'm going to do brief introduction. So my name's Doug Meyer. I'm managing partner of Covenant Technology Partners. So I'm just going to be emceeing this presentation. But the star of the show is Pierre Laframboise. Pierre is the leader of our data and AI solution area. Pierre's been a senior architect focused on designing and implementing data analytics solutions for a long time. I'm going to say more than 20 years. I won't get more specific than that. And he's I'm going to call him a luminary in the data and AI space, especially around Microsoft, and Pierre is regularly in communication with Microsoft product teams in this space as well. So we're very fortunate and glad to have Pierre on the team and also presenting this content to us. So without further ado, I'll turn it over to Pierre. Please take it away.
Good afternoon, everyone. Give me a second and I'll share my presentation here. All right, I'm not going to reiterate through the agenda since Doug already did a wonderful job of that, and I want to make sure we get going. But these are kind of the basic topics that we're going to be covering today. And we're starting really with just some level setting around Fabric, some concepts, some definitions around this to help kind of ground us in the discussion that we'll be having here in a moment. In general, though, this is not, as Doug explained, an introduction to Fabric. So we do have some expectation that you do understand at least what Fabric is, how it's positioned in the analytics world, how it compares to competitors, how it compares to Microsoft's previous offerings, because we will not be going into much detail of that at all. We're really focused on a pretty narrow topic here today, and that's understanding how consumption works within a Fabric capacity and how that translates to cost and how we can manage that. It is a very frequent question that we get with both new clients to Fabric that are just evaluating it, as well as people that have already started utilizing Fabric, but they're not always very clear on how to maybe interpret their bill or to understand whether they have right-sized their environment. So to start with, when we're talking about Fabric here, what the concept that we just need to understand is that this is a software as a service platform. It's very different than a lot of the analytic platforms that Microsoft has had in the past, in that this is a fully managed solution. And it's also quite a bit of an umbrella solution, meaning it covers a lot of data ground here, everything from that ingestion of data all the way to the visualization with something like Power BI. And because of that, it can be pretty complicated. On the surface, though, it's actually quite simple in that we have some SKUs available for Fabric, which we'll again look at here in a few slides, and they have a set price. But looking at that SKU table and taking that and translating that over to what do you actually get for that SKU is really where it gets a little more complicated. And that's what we're hoping to demystify a bit here today. So the first concept that you need to understand is this concept of tenant. This is really no different than any Azure kind of tenant. It surrounds what used to be called Azure AD. It's now Microsoft Entra. And this applies to Power BI, it applied to previous Microsoft products like Synapse, and it applies to just about anything that you're deploying in an Azure cloud today. But you have this concept of the centralized tenant. The reason why that is important to us is because a tenant can have multiple capacities associated with it. And capacities are what you are purchasing as part of a Fabric subscription. And again, we'll go into more detail here about what a capacity actually is. But for now, just understand that a single Fabric tenant can have one or more of these Fabric capacities associated with it. And then those capacities are essentially divided into workspaces. And this is the same workspace concept that would be coming from kind of the Power BI perspective. It's been expanded to cover much more than just Power BI assets. It can cover the ETL side, the data warehousing lakehouse side. And again, we're not going to spend much time going into kind of the types of assets that are available. But again, understand that when we are talking about how things are consumed from a capacity perspective, it's consumed based on what is deployed within the workspace that is then assigned to a Fabric capacity. So let's get into capacity itself. So while this isn't an overview, it is really important that we kind of understand how these different Fabric experiences are organized and how that then translates over to capacity. Each one of these experiences, from the data factory all the way over to Power BI, is capable of leveraging different types of compute engines and potentially very different types of compute engines. And as a unified platform, Microsoft tries to tailor this all under kind of one, again, umbrella, one billing model, one set of capabilities. But at the same time, each of these different experiences also has the ability to generate storage objects. So we have kind of this top line, and then we have this bottom line. And what these end up translating into is compute and storage. And again, the compute is everything that we need to be able to execute, can create, maintain different types of assets within Fabric. And it is decoupled from the storage layer. And this again becomes important because this impacts how it is metered or how it is billed. So compute is billed separate from how storage is. And the way that this is billed can be a little bit different as well. At the base of it, you have pay-as-you-go rates for both compute and storage, but compute also offers the ability to deploy what are called reserved instances. And so you do a reservation for a year to get a discount. And again, we'll look at that in a little more detail in a moment. But all of this is meant to be condensed. So all of those different experiences, all of the different types of activities that can be done in there are simplified into a single pricing model. Today, we'll be focusing solely on the compute side. We won't really be talking about the storage side of this because capacity is essentially what that compute is. So you'll see this term called capacity units or CU, and this is how it's actually applied from a SKU perspective. This is essentially our compute power that's behind the scenes for this. And it is meant to be a universal set of compute power. So if I'm going in there as a data scientist and I need to run some machine learning code, it will deploy seamlessly in the background. I don't have to do any of the deployment work itself. It's managed by the platform. It will deploy that compute for me so that I'm able to run my workload. And that compute then will consume some amount of capacity units. And that's where, again, we'll get into some more detail here of what that is, how it translates. But each of the different experiences has different compute capabilities that will consume our CUs. So all compute operations within a capacity are either in one of these two categories. They're either what are considered to be interactive compute or background compute. This will become a little more important later because the type of compute impacts how it is actually managed by the system, how it's managed by this platform, and we'll go into more detail about that. But at the high level here, interactive computer, these are the things that your users are doing. These are things that you typically don't kick off and then have to wait for. You're expecting to get the results back immediately. So it's any sort of on-demand interaction with these systems. Could be running a report, could be issuing a SQL query to a database. It's those type of things where I am physically in there interacting with something. Now, it can come from multiple tooling because there's a lot of kind of endpoints to Fabric. It could be something like SQL Server Management Studio that I'm using to issue SQL queries against my databases. But it's still, if I'm actively interacting with it, it is an interactive operation. Now, on the flip of that, any of these resources that are either configured manually or automatically, these are all things that are running in the background, and those are classified as background compute. And there will be different meters associated with each one of these. Again, I don't want to overcomplicate this in the sense that I'm talking about there are a lot of different meters, and we'll take a little bit of a look later at what some of those meters look like. But in the end, it's all translated into this single unit of measure called a consumption unit, or sorry, capacity unit. And reiterate this one last time, all of the different experiences within Fabric have unique sets of operations. So there is a lot of variety, a lot of differentiation between these different areas. But again, in the end, it's unified into this single unit of measure when it comes to capacity. So quickly, we'll take a look here at the SKUs. So SKUs that are available are anywhere from an F2 all the way up to the 2048, and that evenly aligns with the number of capacity units that are associated with that particular SKU. And we're not going to go into a lot of detail right here about how pricing works, because pricing is unique across different regions. All the US regions should be normalized to this, but other regions globally may be slightly different. And at its base, 1 hour of CU time is roughly 18 cents. And the way that they calculate this is a month is considered, it's averaged out to be a 730-hour month. And I guess I'd point out that in addition to this presentation, I have a blog post that was just pushed out on our webpage yesterday that acts as a companion for this, that goes into a lot more detail than this presentation does in terms of providing some of the formulas, breaking down some examples. For instance, I do some examples of like how much Copilot costs from a CU consumption perspective and some of that. So if you're interested in kind of those nitty-gritty details, I would absolutely recommend you check out the blog post, and I'll show a link to that towards the end of this as well. So that is the idea behind capacity, but now let's get into some of the details of, well, how do you actually consume your capacity? Because this is what's ultimately important for figuring out the sizing for your environment. So every activity that's inside of Fabric burns some sort of a capacity unit. The rates are going to be different depending on what the actual activity is, but it all burns this single, again, unit of measure. Capacity usage is measured at its lowest granularity as CUs per second. So usually this is looking at how long an operation runs. It's a duration based, usually. There are some non-duration meters, but they will still translate their compute into CU seconds. They have a little note here that though some meters do aggregate at a higher level than the CU second, you'll see CU minutes, sometimes even CU hours, depending on what the actual activity is. But the lowest granularity that you're going to see is a CU second. And so for one CU, you have a total here of 2,628,000 CU seconds in a month. That is the capacity for one CU. So an F2 has double that for a month, and that is what you are consuming against when you are purchasing that SKU. And so one CU second, is equivalent to whatever that small fraction of a penny is. Again, these things do add up, and it ultimately will eat through your capacity depending on the activities you're doing. But that is the basics of it. So most Fabric activities are duration based. And again, there's a handful that are not. An example of one that is not is one I've already mentioned. It's Copilot as an example. All the AI tools in Azure actually meter based on the number of tokens that are sent back and forth between the APIs. And I'm not going to go into necessarily details here of what a token is or how that's done, but there's a translation. So for every inbound 1,000 tokens, that's equal to something like 400 CU seconds. And again, I'll show you a web page at the end that will provide you details of what that consumption looks like so that you can understand what activities are going to cost within the environment. So consumption or your capacity here, though, within Fabric is not static. One of the goals of this platform is to be very performant, and it's also the goal is to kind of get you in and out of an activity as quickly as possible. And we'll have some animations here in a bit that describe this a little bit in more detail, but the concept is called bursting. And so all Fabric capacities are what are called burstable capacities. So you temporarily can be given access to more resources that are beyond your baseline. So if you think about an F2 as an example, you only have 2 CUs to work with. However, you do have the ability to burst that up. Again, automatically, the system manages this for you. You don't manage it. It'll automatically burst that up and give you more capacity so that you can get your job or your interactive activity done quicker. And again, the idea here is to significantly improve the performance capabilities of this, even at the smallest of SKU level. So this is, though, shared amongst all the tenants that are in the same region as you for the same service tier. So let's say you have an F64, you would be put into a pool with other customers that have F64s, and all of the compute that's been allocated for that tier is potentially available to any tenant within there. And so there is a shared pool that is drawn from to allow for this bursting. And as a result of that, there isn't necessarily a bursting guarantee. The dependability is still based on availability. You are, from an SLA perspective, always guaranteed to at least have the performance characteristics of the SKU that you are purchasing, but you're not always guaranteed to get that full bursting capability, which we'll look at what that looks like in the next slide. Again, these things are pre-provisioned for you. It's not something that you manage. It happens automatically. So bursting, though, can, in theory, be dangerous if you burst up to a very high level and now you're eating up potential future capacity. So there are some guardrails put in place. And so your burstable scale factor here is going to be dependent upon which SKU level you have. So you can see that F2 can go up to 32 times fast or higher than that. So it can essentially burst up to be an F64 if that, again, compute is available for your pool. And again, you are always guaranteed at least the 1x, the SKU rate that you had purchased. But this is kind of how that bursting works from that kind of a scalability factor. So to help with bursting, though, and help align that with the SKU that you've purchased, there's another capability built into Fabric called smoothing. And again, the idea here with smoothing is that you are temporarily overutilizing your capacity, but there are periods of time where your capacity is underutilized. And so smoothing takes that overutilization and spreads it out to make sure that that underutilization is also being filled in. So let's say you don't use your Fabric capacity outside of standard business hours, except maybe for some like background loading for ETL and things like that. So you may have many hours in the day where your Fabric capacity is essentially sitting idle. And the idea here is we don't want you to lose what you are paying for. And so the bursting allows you to burst up and essentially kind of pre-utilize that space, and then smoothing comes through and levels it out so it all stays within your SKU level. It's a reallocation of that utilization. So interactive jobs work a little bit different than background or scheduled jobs. The smoothing is typically done over a 5-minute period. It can be extended longer. That we'll look at a concept in a moment called carryover. But background processes are smooth for the entire 24 hours. So let's say you have an ETL process that takes an hour to run. Well, what they will do is take that whatever capacity it was utilizing during that hour, and they will flatten that over a 24-hour period. And so it's not as impactful to your full available capacity. So let's look at some examples here. So this is an interactive example where we have 3 different kind of workloads that are going through. 2 are kind of coming through simultaneously. This is a simulated F64 environment. So the dotted line we have there is our baseline. We have 64 CUs to work with. But again, I want to be able to burst up and get these operations done as quickly as possible. So smoothing will then kick in, and it will take those spikes and it's going to smooth it out over a 5-minute period. Again, the 5-minute period here is standard. There are some areas where it could get smoothed further than that. But instead of, again, over allocating our capacity, we are temporarily bursting, and then the smoothing spreads that out so we're still under our allocation. Similarly, for a background process, a batch job as an example, this might run for a large period of time, and again, it may max out our burstable capability for that period of time. But to prevent it from having any sort of blocking activities or anything like that, the smoothing again will kick in. And the main difference here is this is now smoothed across a 24-hour period instead of the shorter 5-minute kind of period. One of the goals with this, as it says kind of in the third bullet here, is to provide that greater level of flexibility so that we can run background processes even during business hours without impacting your interactive performance. So in a traditional data warehousing world, we oftentimes have to do batch jobs after business hours, maybe even late into the night, to avoid putting that strain on our compute systems, so that it doesn't interfere with business during standard business hours. By doing this smoothing over a 24-hour period, from a capacity perspective, it doesn't really matter when this occurred, because the amount of impact it has is even whether it happened in the middle of the day or happened in the middle of the night, because that whole capacity, that whole consumption is now spread across a 24-hour period. And so it gives some greater flexibility here to when you schedule these things and not have to worry as much about having them impact your interactive performance. So even with smoothing, there may be times when you have exceeded capacity due to bursting. And how this is handled is through a mechanism called carry forward. What carry forward is going to attempt to do is take anything that is above your baseline and find gaps where there was underutilization and fill that in. And you can kind of see again from this animation how it just gets shifted forward and shifted down from that actual capacity perspective. There's some key things to note here that we're about to discuss, though, is that as it is carrying forward, and it'll continue to carry forward and forward and forward, but these carry forward events is an indication that you may be overutilizing the capacity that you have deployed, and it can result in throttling. So throttling here, though, is really focused on environments that are heavily overutilized, because remember, we have quite a bit of period of time. Well, we have a full month worth of capacity here to work on. But if we are overloading that system and we are bursting way above, and the carryover and smoothing cannot level it enough, that is where we end up with some scenarios where the system is going to start throttling your users. And again, this is a very key point here, is that this is an indicator that you are not utilizing the correct SKU level for your workload. There's a lot of work that's gone into designing Fabric to make sure that it has these abilities to burst and smooth out standard workloads without having any impact of throttling. It's trying its best to avoid throttling scenarios. So if you are properly sized, throttling shouldn't ever occur, even during like peak load times, like your monthly close or something along those lines. It also, from a design perspective, it allows us to design these capacities when we are doing our architecture work based on the averages and not necessarily the peaks. And so that's why it does become important for us to kind of understand what that average baseline is going to look like over that period of time. But let's get into some more detail about throttling, because this is an important concept to understand. So first, throttling is only going to impact new requests. Anything that's in flight, anything that is already running, the stuff that actually is contributing to the throttling, will continue until its completion. So this applies to all operation types, even things that, again, are long running. Maybe you have something that's been running for 24 hours because it's a very long load. It is not going to get throttled as long as it was initiated before the throttling starts. So again, this is designed here to ensure that all of our critical operations are able to go through without interruption. It really allows us to have that kind of better reliability around the service. So let's look at kind of the triggers here and the different stages. There are 3 stages of throttling that occurs. And so your initial trigger is when that carry forward has filled up completely your baseline for the next 10 minutes. It's 100% full. There's no more gaps in there. That is the initial trigger for phase 1 of throttling. In phase 1, what it will do is any new interactive operations, and so it's important, these are only interactive operations, they will have a 20-second delay put on them. So if I were to go and attempt to load a report while throttling is occurring, it is going to sit and spin for 20 seconds before it actually goes through. Very annoying behavior. The idea here is you are giving it some gap for that workload that was filling up our capacity to clear out before it goes through. So our second stage, our second throttling, is when now carry forward has reached a full hour of full capacity. At this point, there's no longer a delay on our interactive operations. They are now being rejected. So this is a very bad scenario at this point. And so again, if we size this properly, we should be able to avoid it. But this is the second stage, is your interactive operations. Any activity that's coming through an interactive basis is going to get rejected. The final stage is when carry forward is filled up an entire 24 hours of capacity. At this point, the entire capacity becomes frozen until, again, that deficit is cleared. Remember, anything that was already running will continue to run as it has been, but no new operations will be able to be initialized. That includes both interactive and background. So this is an extremely severe scenario at this point. We will talk about in a minute how we can monitor for these things and how we can try to be proactive about it to avoid it getting to this point. And there are things that you can do if this is occurring in your environment. So we'll get to that in a second. There are, though, a couple really important special cases, some exceptions here. So one, well, first of all of this has to do with real-time analytics, but the first one is around event streams. These are meant to happen in near real time, and as a way of trying to avoid discrepancies in how that real-time stream is processed, it is exempted from some of the throttling. Again, the details of this, I go into a lot more detail around this inside the blog article, so you can get some more information there of how that works if you're doing these real-time thresholds. But it doesn't halt the operation. The event stream will continue, but it will reduce the total throughput that is available for the event stream. But the idea again here is to keep it open so that you can continue to process events. It's just they might be a little bit slower than what was happening before. Similarly on the real-time analytics, so kind of the further downstream from your event streams here is our ability to process those events. These are also exempted from that 20-second delay at initial throttling. However, they will eventually get rejected, but it isn't until you get to that kind of final stage that you're going to have problems with the real-time analytics. So there's special use cases for these two scenarios. So let's talk about managing this capacity a little bit. So one, you do have the ability to scale up and down your skew levels. So this is one of the answers for throttling. If you just have an exceptional scenario where all of a sudden a lot of activity is coming through, but it's temporary, you could temporarily scale up your skew to the next level or even further, depending on how much activity that you have coming through. That initiation process of that scaling it's instantaneous. It should happen essentially within seconds. There is one caveat to this, and that is at that F64 level, and higher, there's some special licensing that is involved there for Power BI. That's very similar to Power BI Premium, where report consumers do not require a Power BI Pro license. That licensing takes roughly or up to 3 hours for it to complete. So it isn't an immediate thing when you skew up. However, the additional capacity that would help alleviate something like throttling does become immediately available. So scaling is one way of dealing with kind of the throttling issue. And again, you can scale both ways. You can scale up and down. So in theory, if you wanted to better manage some of this, although again, it is self-managed through this bursting and smoothing, you could in off hours scale down an environment if that made sense for your workloads. Similarly, you do have the ability to pause and resume. There are a couple important notes though here with pausing and resuming. This is different than the pausing and resuming that was available in Synapse as an example. When you pause here, you are pausing the entire capacity. You don't have the ability to pause individual workloads within here. I can't go pause my data warehouse as an example. Part of that is because there is no data warehouse from a server perspective for you to manage any longer. It's all managed by the system. It's just part of the capacity. So when you do think of pause and resume, and think of that at that full capacity level, but it does allow you to stop essentially billing. If you halt a system by pausing it, all the activities are killed that are going on in there. They will be rolled back or ended, whichever makes sense depending on the operation, and no more billing will incur at that point. There is, however, some downside to resuming. There is a period of time that it takes to reinitialize some of these resources, especially on the real-time analytics side, but it also applies to data warehousing and Lakehouse to some degree. And so the things don't become available, within the second that you resume it. It may take several minutes for some of the workloads to actually then resume. And so it's something to just keep in mind. that it's all, again, it's important on the real-time analytics side because there's some caching and things that occur there, but it does also occur with things like the data warehousing to help speed up Power BI performance. All those caches are lost and cleared out, and they need to be rebuilt after the system is being reinitialized. So resuming allows you immediate access to those resources. It may not be performing at its full capacity immediately because caches need to be rewarmed. That's kind of the main idea behind here. Because of that, you really need to have some strong operational needs to consider pausing a capacity, just because it does have a pretty substantial impact. If this is like a non-production environment, it certainly probably makes sense that you pause it when it's not in use and things like that. But for production, you're better off scaling down than you are to actually shut it off. So let's get in here quickly to the Fabric Capacity Metric app. This is the application that Microsoft provides to help monitor this, to help you kind of break down what your consumption is. And this is also the app that'll act as kind of your starting point to be able to set up things like alerts for scenarios where throttling may start to occur. So there's a couple aspects to this. Again, it is designed specifically for monitoring Fabric capacities. This isn't necessarily the tool that you'd want to use to manage some of the legacy capacities like a P1 and things like that, although they are essentially being transitioned to Fabric, so there really isn't much of a difference any longer. But it is oriented at the whole Fabric suite, not just the Power BI side of it. And again, the idea here is that it is designed to help you stay informed about what your capacity is doing. I will put a pretty big note here. In the Power BI world, the job of a Power BI tenant administrator was pretty light. Maybe occasionally they would have to come in and enable some new features or manage some of those aspects of it. Because of the breadth of capabilities within Fabric, the burden upon that tenant administrator has gone up significantly with being able to manage things like this capacity management so that you don't incur scenarios where you are throttling. And so this role becomes a lot more important than it was previously. So I don't want you to, underestimate how, kind of important this is. So to get the app, this link right here kind of will lead to that app. Again, you can either copy it or we can send it out later. It's just an app that's deployed in Microsoft's App Source. So you can deploy it to your Power BI environment. And it is a Power BI app, essentially. But it's tied into the background statistics of your Fabric capacity. You do need to be a capacity admin to install this. And when you do install it, it'll ask you some questions about which environment are you deploying it to, and there'll be on-screen instructions for how to set it up and configure it. After that, really all you need to do is go into the app and verify that it's getting data by essentially viewing kind of the main dashboard. So the installation is pretty straightforward. You just have to make sure that you're in the proper role to be able to do this. The first area that you'll see is utilization over time. And there's a few different graphs here and a few different tabs that are involved with this. This first one is looking at the CU, and it's going to give you kind of this percentage of interactive and background operations over time, and you can break it down. And the granularity is in 30-second groupings. And you'll see here on the right kind of graph, there's a dotted line. That is similar to the animation I showed earlier. That is your SKU capacity. So whatever that is at is where you are licensed for the capacity. So you can see in this example, all of these kind of red lines, these are examples where they're bursting over your allocated capacity. So that's the first thing, is to kind of look at utilization here. The second tab that you have displays information about throttling, and the throttling information is going to tell you whether you've had any time that's been delayed, any operations that are being rejected, this sort of thing. And you can then also drill in further to see what background operations and those type of things are running that may be actually causing this throttling. And again, this level of information is stuff that you could then utilize to build out some pre-built alerting and that sort of stuff to let you know if you are having some problems here. But in this particular example, it's probably a little hard for you guys to see, but there's essentially a 75% utilization of future capacity for this specific time point, which is, so you have about 15 minutes remaining before, in this scenario, it starts rejecting both the interactive and background. So things are already being delayed in this example. So it kind of just shows you that. And there is a very good set of tutorials for the capacity app that's published on Microsoft Learn that goes through all of this in detail as well. This is really just more of an overview. Then you can also see how carry forward is accumulating over time. There are some overage tabs, so you can see where it's over, and you can kind of see how it gets carried over. Here, it'll show a little bit of how that is done. In this specific example, as he's zooming in here, you'll see those kind of dark blue spaces. That is where it's taken that overage from the bursting and it has carried it forward. So the bursting in this example is the red and kind of those teal green colored. And then the blue is where it's labeled as a burn down here, but that is your carry forward. So that's how it's smoothing some of this out and doing some carry forward. See, I'll go through this little spiel here quick around some of our services, and then I'll jump into a couple web page resources, and then we'll open it up for some questions. But if you are looking for some more information, my team provides a couple services that are directly applicable to this. One, we can do some private lunch and learns, so one-on-ones with your team to educate around, well, really any topic around analytics and AI, or more specifically, this Fabric stuff. Specific to Fabric, we do have a proof of concept and pilot solution that we call a data foundation jumpstart. This is designed to help you guys get started with deployment, where we show you some of the best practices for this and deploy some of your data to act as a template for your team kind of moving forward to turn this into a larger implementation or a project. And then lastly here, we also have a data architect as a service where you can utilize our architects on a retainer on a regular basis to help augment your team, to give you architectural advice, to help you work through solutions, those type of things. This is really good for clients that don't have a full-time architect on staff, or even those that do but are looking for a little bit maybe broader experience than just what is limited to their organization. The last thing I would mention here is Microsoft provides partners with a lot of tooling around how to calculate capacity usage for Fabric. And these are partner-only tools, but we can utilize them on a client's behalf to help estimate ahead of time the type of capacities that you will need to facilitate your workload. So if you're interested in a session where we can go through and assess some of that, that's another thing that is available. And it's a fairly detailed process going into everything from number of users to the size of the data, how frequently it's loaded, to the different also data streams, whether it's real time, whether it's batch, whether you're using data science. There's a lot of aspects to it. So it's very detailed assessment, but it helps you estimate out what your capacity should look like. You know, the more trial and error way is to pick a small capacity, deploy it, do some things, and see how it shows up in the capacity app. But this calculation method and assessment method will be a little more scientific than that and help you align before the project. And just kind of last here on Covenant, we do offer a couple different business tiers here. We do have managed services where we can help manage your environments and keep these things running and healthy. We do software licensing through a cloud solutions provider with Microsoft. So you can license things like Fabric through us. And then finally, my team falls within our business solutions, where these are kind of traditional consulting services. And again, my team is focused on data and AI. So before we get to questions here, though, let me kick this out, and I want to go through a couple web resources for you guys. First off, all of the different meter types in capacity are defined on this page right here. And I can throw this link in chat for you guys so that you have it. But it breaks down the different types of meters. So what will actually show up on your bill, whether it's a background, whether it's an interactive type of operation. And also embedded in here, you'll see other links that will bring you to the consumption documentation. So if I click through on this pilot, the Copilot consumption, for instance, this gives you that translation. So I mentioned earlier for input prompts, as an example, 1,000 tokens is 400 CU seconds. So you can kind of get an idea of that. Now, you will need to have a greater understanding of how some of this works to understand what 1,000 tokens actually means. But in general, all of this sort of consumption information is documented, and you can get there from this page, this Fabric operations page. And then lastly, I mentioned this earlier, but this is kind of the blog post that goes into a lot more detail, breaking down some of the different formulas and stuff that are being used here. And it talks about how the bursting and smoothing, all of the things we've talked about here today work, but it's in a little more detail. It also, throughout this, it links to things like documentation, or in this case, like the capacity metric app. So this brings you to the documentation here. This is full of different tutorials on how to utilize it. It has a lot of the same type of animations and stuff that were used in our presentation here today. So all of that should be helpful.